Okay, we're going to try this again. Um, had a little accident with my new toy. I accidentally erased some stuff, so we're going to start all over again. Today we're going to be solving absolute value inequalities. And just like the absolute value equations, absolute value once again means a number's distance from zero. So if the absolute value of something is less than a certain value, that means its distance is less than that value, so it would be closer to zero than that given number. And if the absolute value is greater than a value, that means its distance is greater, so therefore it would be farther away from zero than that given number. So we're going to use that idea of distance in order to solve some of these inequalities. So looking at the first example, the first thing you want to do is make sure that the absolute value is by itself. In the case of A, it is. So in taking a look at this, if we take a quick look at a number line, we want to look for all those numbers that are closer, because of the less than, to 0 than 5 is. Well, those two numbers that are 5 units away are 5 and negative 5, just like with the equation. So we are looking for those numbers that are closer to 0 than those two. So in between negative 5 and 5. Still getting some stray marks here. So we're going to have h minus 3 has to be between negative 5 and 5. And then we're going to solve this equation for h. So to get the h by itself in the middle, we are going to add 3 to all three places, left, middle, and outside. So when we do that, we end up with negative 2 is less than h, which is less than 8. So the values for h are all those values that are between negative 2 and 8. So to graph this, we're going to plot negative 2 and 8 on a number line. And we're going to graph all of those in between. Now, to graph those in between, excuse me, first of all, the kind of circles we're going to have at negative 2 and 8 are open circles. And we're going to be just shading in between. So we've got all those values in between h. And then the third way to express our solution using integral notation, where the left edge of the graph is negative 2, the right edge is 8, negative 2 to 8. And since we have an open circle at negative 2, it's not included, so we use a parenthesis around negative 2. 8 also is not included, so we're going to put a parenthesis around 8. Now, with the next one, we have a number outside the absolute value. So in order to get the absolute value by itself, we're going to divide by that 2, since it's 2 times that absolute value. So then dividing by 2, we end up with the absolute value of x plus 2 is greater than or equal to 1. So if we take a quick look at this, we're looking for those numbers whose distance from 0 is greater than or equal to 1. Well, if we have 0 here in the middle, negative 1 and 1 are both 1 unit away. So what we're looking at here are those values whose distance is larger than 1 away from 0. So we're on the outside of those values. So to solve this equation, we're actually going to set up two inequalities. We're going to have x plus 2 is less than or equal to negative 1. That takes care of the left part of the graph. or x plus 2 is greater than or equal to positive 1. And then we're going to solve each of these for x. And to solve these for x, we subtract 2. So negative 1 minus 2 is negative 3. Or x is going to be greater than or equal to 1 minus 2 is negative 1. So to graph this on a number line, that's the inequality solution. So our two critical values are negative 3 and negative 1. And we are going to graph these. Since we're less than or equal to and greater than or equal to, we're going to have closed circles at both of these numbers. Both of those values less than negative 3 are to the left. Those values greater than or equal to negative 1 are to the right of negative 1. So that is the graph of the solution. And finally, the interval notation for this becomes left edge of the graph is negative infinity, and it goes to negative 3, but it includes negative 3. So we put a bracket around negative 3 because of the closed circle. And whenever you deal with infinity, you always use a parenthesis around infinity. You should never have a bracket around infinity. And then picks up again at negative 1, and it includes negative 1, so we put a bracket. And to the right edge, infinity. And whenever you use infinity again, you use a parenthesis. And whenever we have two intervals like this, we put that little symbol, union symbol in between. So here are the three ways to represent these solutions. Inequality, graph, and interval. Now in these next two, okay, the first one, absolute value is already by itself. So we are looking for those numbers whose distance from 0 is greater than or equal to 24. Well, we've got negative 24 here and 24 here. And those numbers that are farther away from 0 than 24 is are to the right of positive 24 and to the left of negative 24. So to set this up, 8n is going to be less than or equal to negative 24, or 8n can also be greater than or equal to positive 24. And then we're going to solve each of these inequalities by dividing by 8. Now, one quick review of solving these inequalities. Since we are dividing by positive 8, even though this value is negative, look at what you're dividing both sides by. We do not flip the inequality because we're dividing by a positive number. So that's going to be negative 3, dividing by positive 8 here, n is greater than or equal to positive 3. So that is the inequality form of the solution. For the graph, we have negative 3 and 3 as our critical values. We are going to have closed circles at negative 3 and 3. Those values less than negative 3 are to the left. Those values greater than 3 are to the right. So there is the graph. And then the interval, left end, we're at negative infinity to negative 3. Again, whenever you have infinity, you always use a parenthesis. Negative 3 is included, so we use a bracket there. Since we have two intervals, we're going to use the union symbol. And then it starts again at 3. Since it includes it, we're going to use the bracket. And it goes to infinity. And then finally D. again, we're looking for those values that are farther away from 0 than 5 is. And I'm getting stray marks because apparently I'm getting too close to the screen. So if we look at this graph, we have -5 and 5. And those values that are farther away from 0 than 5 is are to the left of -5 and to the right of 5. 0 were here. These numbers would be farther away from 0 than 5 is, so would these numbers. So we are going to set this up. Okay, picking up again, I accidentally hit the touch screen, so I got to be careful where I'm touching this. But to set this up, we have I'm going to get the right, we've got 2x plus 4. Now those to the left are going to be less than or equal to -5, or 2x plus 4 is going to be greater than or equal to +5. And we're going to solve each equation individually. First thing we're going to do over here is subtract 4. So 2x is less than or equal to -9. And then we are going to divide by +2. Now, since we are dividing by +2, we are not flipping the inequality. So that's -9/2. Some of you would maybe prefer to write -4.5, which is fine. It means the same thing. So to solve the other part of the inequality, again, we subtract 4, so 2x is greater than or equal to 1, and x is greater than or equal to 1/2. So we have that or in the middle, so there is the inequality symbol. So to graph this, our critical values are -9/2 and 1/2. We would have closed circles at both. And continuing on, I really have to be careful where I'm touching this, otherwise strange things pop up. So to continue the graph, we've got closed circles at -9/2 and 1/2. Those values that are less than -9/2 are to the left of -9/2. Those values greater than 1/2 are to the right. So then the interval notation for this solution, starting at the left end of the graph at -infinity, and goes to -9/2, parenthesis every time you use an infinity, and since it includes -9/2, we are going to have a bracket around -9/2, and since we have two intervals, we're going to use the union symbol. And then we are going to, for 1/2, bracket at 1/2 to infinity. And again, when solving these inequalities, you want to write all three solutions: the inequality, the graph, and the interval notation for these. And that is the last section of this unit.